Hello and welcome to day 4 of Advent of Code 2024. In today's challenge, we're going to find the word xmass in a 2D array like this. This xmass can be found like horizontally going to the right or horizontally going to the left like this, vertically to the bottom or to the top, or diagonally in 4 directions like this. So this is a classical problem that we need to find the word in a 2D array of characters. So in order to solve this, I have converted this into a 2D array, and then I would go and search for the word in all the different directions. So let's go and see how I did it. So here, again, like always, I'm getting the input from this string and using data.split by a new line, I would split it into different lines. So this part would give me an array of these strings. Item 0 is this one, item 1 is this one, item 2 is this one, and so on. And then I would split each of them into individual characters. That happens here when we get each row and split it by empty string. Then I would grab the length of the table to give me the rows and length of the first row to give me the columns. Then I have the word xmass. I will convert it to an array of characters because later on I want to map through this word. And here is the count value, which is by default 0, and whenever I found an xmass in any direction, I will add 1 to this count. Here I would have 2 for loops to go through the 2D array. So one for loop for the rows and one for loop for the columns. So in the first for loop I would grab this, and in the second for loop I would grab each of these individual characters. To find the word, I would go and check that if this word that I have here, which has converted to this, does this array can be found inside the table or not. To do that, I would go and say, okay, for every word that I see here, get that character, which is this one, and then the index, which is 0, 1, 2, and 3, and then check that character against the table that I'm already in, going one step ahead. So for example, if I am, let's say here, I would be at some I at some j. I would get the word x, m, a, and s. I would check the x against the m that is here, which would fail, which will result this every to be false, so I wouldn't continue anymore. Then let's find another one which has the here, for example. If I found this one, if I'm here, then if I am here, I would get the x. Then in the next iteration of the word, I would go to m here, and then I would move to the m here, then to the a on the word and to the a here, then to the s to the word and to the s here. So this will be true, which means that for every character in the word at this position that I have, I can find a xmass word. So this will be going horizontally, like in this direction, like this. Now we can do it in this direction, to bottom, to top, and diagonally as well. Now here we're going horizontally but to the left. These two are for vertically, going up and going down, because we are changing the row by adding to this. So this means that we are going down, checking vertically to down, and this is checking vertically to the up. And these 4 are for the diagonals. Each diagonal is represented to one of these. So for example, this one, I plus and I plus, means that from here go one row, which means here, and then one column, which means here. So from here to here to here to here, so this diagonal. And again, for this diagonal, and this diagonal can be found in these three parts. And one more thing is that I'm using this chain operation here that will say that if this I plus index goes out of the bounds, then don't check it. So for example, if I am here, there is no row above this, so going here would fail because there is no row above this to check. Okay, and basically this is the part that would find all the occurrences of X mass in the table, and in the end we just log the count, and that's it. We are done. So this is the error. Let me remove this here. Now on part 2 it gets a little bit more interesting. Now the word X mass is not what we are looking for. We are looking for a mass in form of an X, something like this is what we are looking for. So instead of finding X mass, we need to find a mass but in form of X. So this can be written in different ways. So it can be M here and M here and S here, S here, or for example M's are here and S's are here. This is another valid mass. So the tricky part is to find all the different combinations that would give us the mass in form of X. Then the rest would be easy. So I figured that out, and this is like basically like this. Let me remove the comments from here. So these are all the 4 possibilities of the mass. So 2 M's up, 2 S's down. The A is always in the middle. 2 M's are on the left, or 2 M's are on the bottom, or 2 M's are on the right. You can see that the M's cannot be on one diagonal, so because it wouldn't make the mass, it would make mam. So these are the 4 possibilities that make the word mass. So if we figure this out, the rest is basically easy. Because the A is always in the middle, I would go and find the A, then I would check for the M and S around it. So again, another for loop, just like here, on every row and every column to find every character. And if I found an A in that character, if I don't find A, if there is an M, X, or whatever, I'm just ignoring it. I would just find A and then check all the 4 corners against it. Now, then I would check that these 4 ifs, big ifs, are basically all of these conditions. So for example, this one is, if the one before it to the left, this one, M, and this one, M, and this one, S, and this one, S, which is this one. So I minus 1 and J minus 1 will point to this. I minus 1 and J plus 1 would point to this. So I minus 1 will go 1 row up, and then if we go J minus 1 we would end up here, and if we go J plus 1 we would end up here. And again I plus 1 and J minus 1, we would go 1 row to the bottom, 1 column to the left would be this, 1 column to the right would be this. So if this has happened, we have found the mass here in form of X, with good to go, we add to the count. Otherwise we check for this one, basically that is done here, which is this one, and then this one, and then this one, that is done here. I minus 1, J minus 1, I minus 1, J plus 1, and so forth, and basically the last one. So these 4, if we found any of these, we would add to the count, and then in the end that's done. We just log the number of counts, but we need to remember to reset the count because the count has some value up here. And that was it for today's puzzle. Hope you have enjoyed the video, and see you in the next one.